Okay, hello everyone. This is the TM105 Introduction to Computer Programming, and this is the first recording of meeting 3. There will be 2 recordings in total for meeting 3. So this is the first part of meeting 3, and then there will be another recording for the rest of the meeting 3 material. Now let me go to the objectives. The objectives of meeting 3, first, to learn more about operators. You see the first objective, division and the modulo. The modulo was presented previously, but it was mentioned that it will be discussed later, so we will see it today. And division, it's not as easy as other operators because the division symbol or the operands that you send to the division operator affect the outcome. So we will see how division works. Now we have introduced if-else statements and we saw how to use them. There is something called nested if-else, and I will start with a flowchart to show you why we need the nesting if-else. And then we have the several checks in one if. We'll see the Java primitive data types. We already saw the int, the double. These are the primitive data types. I will discuss more about these data types. And casting, how to cast one thing to another and how to compare two strings. Now there are other, of course, more topics such as the compound assignment, the unary increment, decrement, the loops, whether for or while loop. You see this presentation introduces both loops, however it only gives examples of for loops. We will see loops in more details in later meetings, so we will just introduce loops over here. So this will be split into 2 and you need to watch both recordings. Now let me start with the first part, which is I will start directly with the nesting of if-else. Basically, no. Here, let's start with the operators. What can we do with operators, and then I will go to the nesting of if-else. I will explain a flowchart and definitely give an example. Alright, so here's my NetBeans. I will start a new project, and as usual you can keep everything, just make sure Java application selected. So next, keep the title, keep everything else, just click on finish. Alright, few seconds, it will create a new project. Okay, so here's my new project. Let me zoom in and let me remove the comments, only the comments, just for clarity. You see the comments /* until you reach the */. So remove only the comments for okay, you do not have to remove them. I'm just removing them for clarity so that I can focus more on the code and you can just see what I'm doing. Let me start first of all by doing some operations. Let me assume I have two I have two here, integer I, 2 variables, and double D. Now this is similar to one of the exercises. I will give different values, but you can try the exercises at a later time, the exercise 1. So integer I and double D. Now let me start by saying that D is equal. Alright, I need to explain the importance of division and why do we have two different division operators. D is equal to, let me divide 9 by 2. Alright, let's put spaces for clarity. And let me print this value. System.out.println, print the value of D. So D is 9 divide 2. And I am trying to print the value of D. Now we would assume that if I divide 9 by 2, I would get 4.5. So we would assume that the result is going to be 4.5. Well, the result is not going to be 4.5. The result is going to be 4 only, but since I am printing a double, it will be 4.0. Now let's see why. Let me run this. Alright, here's what I mentioned. You can see the value is 4.0. Well, what really happened? 9 divide 2, alright? 9 divide 2 is supposed to be 4.5. So Java performs the division. However, 9 is an integer and 2 is an integer. So Java does not continue with the dot 5. You see, 9 divide 2 is simply 4 because the 9 is an integer and the 2 is an integer. Java is going to assume that what you need is an integer. You do not need any fractions. You do not need the decimal place. This is because in the CPU there are two ways of handling the division. There's the integer and the floating point. So Java is assuming that because the 9 is an integer and the 2 is an integer, that you need the result to be an integer. So the division does not continue with the decimal part. So 9 divide 2 is 4. Well, it gave me 4.0. Yes, because if I put, notice the following, if I put d equal, let me use another value, d equals 6, and I print d, you see d is a double, 6 is an integer, so let me run it. This will give me 6.0. The int needs 32 bits and can be promoted to, let me put over here another comment, to a double that takes 64 bits. You see, the int is a number. It can be promoted. It can fit inside another number that can occupy more data. But when you are printing a double, Java is always going to assume that this value you are printing, because it's a double, it needs to show you the dot 0. So when you put 6 in a double, Java is going to make it 6.0. Alright, now one thing to add, and this is one of the objectives, is this is called casting. You see, I placed, here let me put some spaces to see it by itself. Inside the method println, before I print a double value, I wrote int in parentheses. So now I am printing the integer value of d. So if I run this, I will get 6. Well, what if I put 6.5? Now the comment doesn't make any sense anymore. Let me remove it. And let me run this. You see, I still get 6. Let me put 7.9, for example. If I run it, I get the 7. The integer part means that everything from the decimal onward is going to be ignored. Alright, now let me repeat this. Let me repeat this with another example. Let's go back to having, like, for example, 7 divided by 2. We know that the result should be 3.5. So 7 is an integer, no decimal. 2 is an integer, no decimal. So the result is basically 3, not 3.5. When you print it, it will be 3.0. So this is 3.0. Well, what if I divide 1 by 2? You see, this is half, 0 dot. So 0, you need the dot, means you stop. So the result is 0.0. Because it's a double, it is 0.0. Double, you always have the dot 0. You see, the meaning of 0.0 is the same as 0. However, Java is going to always give you, when you print a double, the value after the double. Alright, how to fix this problem? To fix this problem, you can force one of the values to be a double. You see, 1.0 divide 2. Now, your operands are not both integers. One of them is a double. The other is an integer. So now this division is going to give you decimal places as well, because one of the values is a double. So this is 0.5. Now this is the same as dividing 1 by 2.0. It doesn't matter which operand you make it a double, and this is 0.5. Alright, the main problem is when you have two integers. Int num1 is equal to 9, comma, num2 is equal to 2 semicolon, and if you want to divide num1 by num2, you see now you cannot have, now you are forced to use integer division. You see, this is a major problem. I have num1 and I have num2. Both are of type int. I cannot put over here 9.0. You see, this needs to be a double. So assume that I already have variables that are integer and I need to perform a floating point division, not an integer division. So this is, again, as I used casting before, you can convert the value of one of them. You are not converting the variable. When you put a cast before a variable, means you need to take this value and convert the value. Now you can use double. See, I am converting num1 to a double and then dividing it by num2. So now I will get the division, floating point division, which will give me the 4.5. If I remove this double from here, it is an integer divided by an integer. So 9 divided 2 is 4. Put it in a double, it becomes 4.0. So the result is going to be 4.0. So be very careful with your divisions, and whenever you have division of integers, always try to convert one of them to a double if you need the value to be converted to a double. Alright, now there are a lot of examples. Let me open the exercise. This is the meeting 3 exercise, and you can test everything. You see, just declare int I and double D. Try to write each and every one of them and see the result. Before writing them and trying to make sure about the result, try to solve them yourself. The solution is available on Moodle, but try to solve these yourself. This is an excellent summary for all the divisions. Now there are some modulo operators over here. I will cover the modulo, but you can see we have casting to double, casting to integer, and you can trace each and every one of them. Alright, I will prepare this later on. I will be solving this exercise. Anyway, now let me go back to learn about division. This is one of the objectives. And modulo, I will explain modulo, and one of the objectives is to cast. We saw casting. I already casted to a double. Now let me go to the modulo operator. Here's my NetBeans. Let me remove the following. I have an empty main function. Integer. Alright, I need an integer. This integer is going to be a remainder. Int remainder. This is equal to, let me start with the 9. This time I will use modulo 2. If I divide, let me remove the output. If I divide 9 by 2, alright, when you divide 9 by 2, you get 4.5, because 9 by 2, you have the part that can be divided is actually 8 by 2. So 8 by 2, and you have the remainder, which is 1 divided 2. You see, 9 is 8 and 1. So as if you are dividing 8 by 2, and then you are dividing the 1 by 2. So the 8 division 2, this gives you the 4, and 1 division 2, this gives you the dot 5. So this is like 4 plus 0.5 in mathematics. So 8 divide 2 is divisible. 1 divide 2 is a fraction. Now you see this number 1, this is what we call the remainder, because you divided a large portion of the number that can be easily divided, and then you are left with a remainder, a small portion that cannot be divided as an integer. You need the decimal. You see, a fraction, 1 over 2 is a fraction. It's part of a number because the numerator is less than the denominator. So once you have this fraction, this is the result, this is the remainder, this is the modulo. So now if I try and print this remainder, the result is printing it is going to give me 1, because this is what was left. You see, 1. This is what was left. Alright, let me do another one. Let me do another example. Now let me assume I am dividing, let's see, 8 by 3. I am dividing 8 by 3. Alright, the first part. What portion of 8 is divisible by 3? You see, 8 is not divisible by 3. So you check. Is 7 divisible by 3? No. Is 6 divisible by 3? Yes. So 6 divide 3. This gives you 2. And you are left with 2 divide 3. So this is going to be 2 plus, and you know this value is the 0.6666 repeating, okay? Repeating number. Well, we do not need to worry about the actual division, the actual values. This is not division, sorry, my mistake. This is modulo. This is modulo. We are discussing the modulo operator. The modulo operator. So 6 divide 3 is 2, and you are left with 2, which is a number less than 3. Now, of course, you can say that 3 divide 3, and I will be left with 5. You see that this is not a remainder. 5 divide 3, you still have 3 divide 3 again, and then 2 divide 3. So this is not a remainder. The remainder is when you are left with a number that is less than the denominator. Now this would give you 0 dot something. So this is your result. So when I print 8 modulo 3, the value of 8 modulo 3, I will receive 2. So let me run it, and this is it. This is the 2. You see, the remainder is just 2. The value you would get is always going to be less than the value you are dividing by. Let me take another example. I would copy this, and now let me put over here. Of course, I cannot redeclare. So let me put, instead of here, I will put it directly below it without declaration again, because remainder is already declared. So let me put 9. Well, 9 is totally divisible by 3. Nine is totally divisible by 3, and I do not have a remainder. You see, there is nothing. 0 would be left, because 9 is a multiple of 3. When you check the modulo of a number by another number where the first one is a multiple of the second, you get a 0. So this is a divisibility check. I am checking, is 9 divisible by 3? if I get a modulo which is 0, you see the result. This means that I was able to check that 9 is divisible by 3. Alright, now let me do one more. What if I directly put a number which is a fraction? Well, there is no division, nothing to divide. This is 0 dot something. You see, a number that is smaller than the modulo. So the result is definitely 1. It is already the remainder. Here's the result. It's already the remainder. So when you divide 1 by 3, you get 0 dot something. So this means that you already have the remainder. Alright, I will do a small example about these using the if statement. So let me directly do a part of an exercise. Actually, let me do one of the exercises. Here, let me go to the exercises. Prompt the user to enter 2 positive. I will do this one, number B. Prompt the user to enter 2 positive integers and display on the screen a message if the first integer is a multiple of the second one. This means if you divided, do you get a 0 or not? Otherwise it's not a multiple. Okay, so I will do this number B. Now I will use the same one. I need to take input from the user. So this is my import java.util.scanner, and let me declare the scanner is equal to new scanner of system.in. Now I need to take from the user 2 values, so int num1, num2, and let me put over here remainder, even though this could be easily done in the if statement. No need to write it. I will remove this remainder at a later time. Now let me take the input. Let's provide a prompt. System.out.print enter 2 integers. You see, I requested both integers at the same time, so the user is going to definitely put a space between them, or put each one on a line by itself. It doesn't matter. So this is num1 is equal to, use the scanner input dot next int, and num2 is equal to input dot next int. You see, I read both numbers. One prompt, just read both after each other. Now the if statement. If before the if, actually, I added the variable remainder. So this is remainder is equal to num1 modulo num2. You see, I performed my operation. Now I can go to the if statement. I will reduce the font a little bit to have more space over here. Alright, now I can write my if. If remainder is equal to 0, and you use the double equal. No need for curly braces because it's only one statement. So system.out.println, and you can put over here num1 concatenate is let me put, alright, instead of is divisible, is a multiple of and concatenate with num2. Else system.out.println num1 concatenate is not a multiple of another concatenation num2. Alright, so I performed my test, I performed my remainder operation, and I checked it. If the remainder is 0, it's a multiple, otherwise it's not. So let's do a test. Alright, enter 2 integers. I know that 9 is a multiple of 3. You see, I entered both integers right away. 9 is a multiple of 3. because if you try to divide them, you get a whole number. 9 divided 3 is a 3. Let's run it again. 6 and 3. 6 is a multiple. 6 divided 3 is 2. 6 is a multiple of 3. Again. 9 and 4. You see, 9 is not a multiple of 4. You get the 2.25. So 9 is not a multiple of 4. Alright, now one update. You see this variable remainder? I used it just to check its value. So basically, there is no need for it. Take the following, Ctrl C. Remove remainder. Put it instead of it. And this one I do not need it. This one I do not need it. Well, the only problem when you use something like this, okay, you see this is valid, this works. But when you use something like this, you need to make sure which one takes precedence, which one comes before. Is it the modulo or the equality check? Well, this is very logical that you are going to perform the modulo. The modulo has a very high precedence, just like multiplication and division. And then you will perform the equality check. There is a slide at the end of the material that discusses the precedence. Here, let me put this slide. Alright, here's the slide. Notice that I will come to this unary postfix in a few minutes at a later stage. I will come to these, or maybe in the other video, doesn't matter. But what we have taken last meeting is that the following, multiplication, division, and modulo, have higher precedence than plus and minus, and you know this from mathematics. Well, where does the checks come? All the checks come at a later stage, whether the less or equal, greater or equal, equality, and inequality. All of these come at a later stage. So now you know that if you write some sort of expression and then compare the value of the expression, the comparison is going to be calculated at the end, and this is very logical. This is very logical. Alright, let me go back to NetBeans. So, in case this is confusing, add parentheses. You see now, the value of num1 modulo num2, compare it with 0. So you can do it like this, with parentheses, or keep it without the parentheses. You know the precedence rules. And let's try it out one more time. Let's say if 10 is a multiple of 5, so here it is, 10 is a multiple of 5. So I just saved one of the variables. I did not need it. I used less space in coding. I provided only one prompt. You see, I placed all my variables under one declaration. So I'm trying to reduce the code as much as possible. No curly braces, because only one statement for if, no curly braces, one statement for else. But you could have written it with everything you need. 2 prompts, 2 everything. It is the same. It is the same. The same result. You are getting the same outcome. Alright, so let's go back briefly to the slides. Here, let me put the slides again. Alright, you see, among the objectives, learn about division and modulo, this is done. Learn about casting, this is done. Now, nested if else, I will do the nested if else, and then I will discuss more than one condition for an if statement. So let me go directly now to a few of the slides. You see division in Java, you can check the following. This is 7.7 divide 2, print the result, you get 3. And 7 divide 2.0, it's a double, you get 3.5. This is an example. You can do this example. The modulo operator, when you perform modulo 2, as in the slides over here, when you perform modulo 2, the outcome is either 0 or 1. So you can really test if the number is even or odd. You see, a number that is divisible by 2. Take a look at the following example. 7 modulo 2. You see, 7 is not divisible by 2. 7 is odd. It will have a remainder. Now, if you divide 6 by 2, 6 is divisible by 2. The result is 0. And when you perform modulo, the result is any number from 0 up to 1 less than. So when you perform modulo 2, the result is either 0 or 1. When you perform modulo 3, the result is 0, 1, 2. When you perform modulo 4, the result is 0, 1, 2, 3. When you perform modulo 5, the result could be 0, 1, 2, 3, 4. So this is an example over here. You are highly advised to run this example yourself. This example, make sure to write it in your NetBeans and check how to test if the number is odd or even. Alright, now I will go to nesting of if-else. We saw if-else statements. But what is nesting of if-else? Let me go to my pencil software and let me try to show you how do I need a flowchart. I will do a flowchart very similar to what I did in a previous video. Okay, this is going to give me a hard time. Alright, anyway, let's do this like this. And this is my start. Okay, I will increase the font a little bit. Alright, this is good enough. This is my start, and I will take a number from the user. So let me use this symbol to take a number from the user. Alright, just a second. I need to. Oh, here it is. Alright. So I need to read number. I will increase the font a little bit. Okay, and let me increase the size. Alright. Start and then read number. I will put a connector and just connect these two together. Great. Now, what I did in my previous flowchart is put a decision. Put a decision and test. In this decision, I tested if the number is greater than 0. So let me put over here, is number greater than 0. Let me increase the font. Okay, this is my decision. So after I read the number, I can test the number if it is greater than 0. Let me put the connectors, join everything together. Now the outcome, whether the number is greater than 0, is yes or no. So I will add over here an output, and this is the way we did it. Actually, I will modify a little bit. I will assume that if number is greater than 0, now this would be the yes part. So I will do a slight modification than what I did in my previous example. All right, slight modification than what I did in my previous example. Number is positive. Okay, to give this some meaning, so you need to, okay, first let's put it over here. Let's put a connector, connect these two together, and let me get text, and let me put over here true, like as if this is the outcome of a condition. Okay, so is number greater than 0? true or yes, this means number is positive. You see, this is my algorithm, this is my logic. Now the other path, the number is not positive. Well, not positive, it has two meanings. Now what we did last time is that we already provided no, number is not positive. Well, what if I need to check whether the number is positive, negative, or zero? Alright, I need to perform three different checks: number positive, negative, or zero. The first check gave me if the number is positive. Now if it is not greater than zero, means it is either zero or negative. So now I need another check. I need to do another check. So let me get my decision. Now if the number is not positive, I need to perform another check. Now my check, you are free to do anything you want. I will put is number less than zero. You see, I am checking if the number is a negative. Now let me update my first decision. I would put over here a straight connector. Alright, here it is. Now okay, this is number less than zero, and let me put plain text. So this is false for the first one. Let me put it over here, and let me increase the font. Alright, now another check. You see, the first check took me to the other check. This means that to reach this check, this decision, you can only reach it by performing the first one. You see, this is nested. In programming, this would be placed inside one of the branches of your first if condition. So this is a condition that you only reach it based on a previous condition. So this is a nested condition. Now let me put over here, actually I think I can copy this, and I can put over here. Now it's not number is not positive, no. Now I know it is less than zero. I know that the number is negative. I know that the number is negative. And let me copy this true. I'll put it over here, and let me get a connector. This is the flowchart, straight connector. Let's connect this, the value for true for this decision, to this thing over here. Now if the number is not greater than zero, you go to the second one. If the number is not less than zero, so it's neither greater nor less, so you can directly put over here. Let me remove it. Let me just copy this. This is better. It's already the same shape, the same size and everything. So I can directly put over here number is 0. And let me get a connector, a straight connector. Make it straight. Let's copy the false, and this is false. Alright, now let me put the end. Okay, we call this stop. So this is when the program is going to stop. Now remember, in my last design I placed just connectors directly reaching the stop. Well, this is true. You can have connectors directly reaching the stop, or because you have several condition checks, it would be better to show where the conditions are merging together. So let me do the following. Let me expand my design a little bit. Let me move them all together over here. Here it is. Alright, I'll put it like this. Now I have a connector I can use. You are free to use it, or you can just join everything together, it doesn't matter. So let me go to this one. Let me put this one over here. Let me put a connector. I will go to this one and I will connect it. You see, because I have more than one if. You see, this is what I did over here. This is one whole if with true and false, and it ended over here. Now the design is a little bit clearer using this connector. So this is why we have a connector. If you go back to the meeting one slides, you see that the connector is simply just a circle. You can put a circle, not necessarily filled. You can see it in the slides. So you can just put a circle shape, a hollow circle shape. Now let me add a connector. Now this connector is for my bigger if. You see, the first if, this is the first branch of the if. Here it is. And let me put a multi-segment over here. Okay, I'm not sure. Yeah. All right. You see, the problem is that I might need to connect them. No need for multi-segment here. Let's have a curvy connector over here, and it will curve. So yes, this would be better. So let it curve over here to this one, and let me put a curvy connector over here at the bottom. Now I will go from this path. Okay, I did a small mistake. I will fix it. Let me fix my mistake. My mistake is that I need to go from this connector. All right. Now here's my design. Now I started. I read the number. If number greater than 0, then yes, number is positive, and that's it. You finished. Otherwise, another test. If number less than 0, if it's true, yes, number is negative. Go to the connector, stop. Otherwise, number not positive, number not negative, number is 0. Go to the connector and stop. And I have 3 different outputs. All right. Let me implement this design using NetBeans. So let me go to NetBeans. Here's my NetBeans. I will keep the same project. I will keep using the same one, and I already have my scanner imported and declared. Now int number. This is a number that I will be taking from the user. So let me provide a prompt system.out.print enter an integer. Let me take the integer and put it inside the variable number. So number is equal. I will use the scanner input dot next int. All right. Now I need to start my testing. If the first test, according to my design, if number is greater than 0. Now let me put curly braces. This would make it easier to follow. If number is greater than 0, that's it. Provide an output, system.out.println, and you can say number. You can concatenate it. You can put is positive, or you can say the value you entered is positive, or just provide the actual numbers. For example, the user gave you 9. 9 is positive. Now else. You see, this is the other path. Here it is. This is the other path. The else is the other path. You need to perform another check. You know that if the first condition is false, which means number is not greater than 0. Not greater than 0 means it is either equal or less. So this else means that the number is either equal or less. If you need to differentiate between these two conditions, perform another test. If perform one of them, number less than 0, I will use curly braces as well. I can provide system.out.println number, I will concatenate it, is negative, and I will put an else over here, curly braces as well. Here, let me decrease the font one more step. Alright, system.out.println number is 0, or you can put neither positive nor negative, so it's really up to you. This is just as example. Now I use the curly braces just so that I can click over here and show you that you see that this whole if else from line 16 to line 21 is inside these curly braces. You see, this is inside the following two curly braces. So this means that this whole if else is nested. Here it is. Remove it. Not Control Z, sorry, I wanted to use Control X. Here, let me select it, Control X, remove it. You see, here's my else. Control Z, return it. It's inside the else. So this is nested. You can nest inside the body of the if, or nest inside the body of the else. Now let me run it a few times. Enter an integer 9. 9 is positive. Enter an integer negative 9. Negative 9 is negative. Enter an integer 0. 0 is 0. Alright. Now let me remove the curly braces. You see, the if statement has one line, so no need for curly braces. Let me go to this if else. This if condition over here, the body is just one line, so these are optional. Now this else over here, the body is just one line, so these are optional. Now this else has a single statement. You see, an if else altogether is considered as one statement. So even this curly brace is optional. So this is the same exact program with the same exact outcome, but written using less number of lines. Alright, you can use curly braces or you can avoid them. It doesn't matter. Alright, now let me go back to the slides. You see, nested if else. This is the example that I did. 3 different alternatives. This is the flowchart similar to the one that I did. You see, here's the inner if, here's the outer if. You can check this flowchart. And here's the program that we just wrote. I use the println instead of printf. You are free to use any one you want. %d is for printing an integer, and %n is for going to a new line. So you are free to use printf or println. Now another example for nested if else. You see, checking the score and checking more than one condition. I will do the check of more than one condition as an example, but first here's the flowchart. You see, check the first one, false, check the other, false, check the other. You have several nesting inside each other. Alright, here's the example, and it's showing you that when you have an else if, be sure to put the space between them. Now be very careful that an else does not take parentheses. Alright, the else does not take parentheses. But when you write an if, you can put it next to it and put a space between them. So if no, else another if, else another if. Well, this is another way of writing it. You can try these two and choose which one you like more. It's telling you that this one on the right is better. Well, not necessary. This looks nicer. This looks nicer. Alright, now here's the code altogether with tracing, showing you that if you provide the score 70, the first condition false, the second false, the third yes, because 70 is greater or equal, then it will print, and then you go outside the if. This is an excellent slide so that you can trace the code that was just written before. You see, suppose the score is 70, the first condition, if the score greater, no, 70 is not greater. So you go to the else. Now inside the else you have another if. Score is still 70. Is 70 greater? No. So you go to the else of this inner if. You see, here it is. You go to this else. There's another if condition. Is the score greater or equal to 70? Yes, 70 is equal to 70. True. So you enter the if. This is the body of the if. And once you do the body of the if, that's it. You do not do the else. So you go outside after this whole if-else block. So you exit the if statement. Alright, now how to test more than one condition. You see, I will do this test, these all together. You can use the double AND when you need both conditions to be true, and the double OR when you need either one of them to be true, the exclusive OR when you need only one of them to be true, and the NOT, this is the opposite of what you have. You can check the tables, they are very clear, self-explanatory. This is the table for NOT. So if the value is true, not to true becomes false. So if age greater than 18 is true, not age greater than 18 means age is not greater, so this is false. And this is based on the values that you have in the assumption. So check these truth tables. There's the truth table for the AND. AND means both conditions should be true. So if both are false, the result is false. If one of them is false, result is false. If both are true, result is true. Make sure to understand this table well. You have the OR. OR means at least one of them should be true. So if both are true, it's fine. Check the truth table. Make sure to understand it with the example. And the XOR means only one of them must be true. You see, if both are false, the XOR is false. If both are true, the XOR is false. Otherwise, only one of them is true. Alright, now here's another nested if else. You can read these few slides, and then the primitive data types and checking for strings and so on. I will not continue this part in this recording. I will stop over here for the presentations. However, I will do in this recording one more exercise, so this will be covered in the next video for meeting 3. I will do one more exercise, which is exercises D and E. Exercises D and E together. I will do them as one whole exercise, or maybe I will do them as 2 exercises. You see, now I need to use multiple conditions. I need to provide the academic status of an AOU student. If the GPA is greater or equal to 2, I need to say regular, that there are no problems. If the GPA is less than 2 and the number of warnings less than 5, he is warned. So you see GPA 2 and he received 4 warnings, he is warned. If the number is the GPA less than 2 and he already received 5 warnings, then he is dismissed. That's it. So the program should start by reading the GPA as a real number. Then test if GPA is 2 or more. There are no warnings, so the program should not read the number of warnings. Otherwise, if it's not 2 or more, read the number of warnings and provide the coding. So you have a nested if, but this if is nested with other code, other program. So let me do this example, and then I will modify it to example 4. Let me go over here, and I will start from scratch, file, new project, file, new project, Java application, next, finish. Alright, again I will remove just the comments. Be careful not to remove any other non-comment line. So just the comments for clarity. You can keep the comments, it doesn't matter. I'm just removing them for clarity. Alright, you can keep them yourself. Now this program is going to take input from the user. So prepare it. Import java.util.scanner. Declare the scanner. Scanner input is equal to new scanner of system.in. Now I need to start by reading a GPA, and it should be a real number, so double a GPA. Now you can directly declare the number of warnings, or you can keep it for later, it doesn't matter. You see, whenever you need to test a value, it should be declared before testing it. I will not declare it over here, I will keep it for later, but I can add it over here, it doesn't matter. But it's not a double, the number of warnings is a number, so it should be an integer. Now let me start with the first part. Provide a prompt, system.out.print, enter the GPA. Read it. GPA is equal, use the scanner, it's called input dot, and of course it's a double, so I use the next double. Alright, now my if statement. If GPA greater or equal to 2, you see greater or equal, you could do it in one statement. You can compare it with 2.0 or 2, it doesn't matter. Now over here you can directly provide the output, system.out.println academic status irregular. Alright, let me go back to the exercise. You see, regular, if GPA greater or equal to 2, I did this part. Else, now I need to read the number of warnings, and I have two conditions based on the GPA and the number of warnings. Now it's really only one condition, because if a GPA is not greater or equal to 2, then this is included in your else. So now over here, this else needs curly braces, because I need to read a new variable. So system.out.print, enter the number of warnings. I need to read it in a variable. I do not have the variable, declare it. Int warnings is equal to input, this is your scanner, dot next int. Now I can perform my test. You see, I already know that over here the GPA is less than 2. So if warnings is less than 5, system.out.println, let me copy this, academic status warned, else I would copy this, I would put over here dismissed. Alright, this is it. I did not have multi conditions in my if, so I will do another small program for multiple conditions. Now let me run this just to check what I am doing. Enter the GPA, let's say 2.3, academic status regular. Enter the GPA 1.9. You see, I am requesting the number of warnings. So else, enter the number of warnings. Now I am in the else, and I am waiting for this next integer to put it in warnings 2. So warnings less than 5, it will say warned. So academic status warned. Let me run it again. Enter the GPA 0.87 enter number of warnings. Now over here I'm testing for anything not less than 5. So if I just put 5, you see, if warnings less than 5, no, 5 is equal to 5, so this will go to the else. So this will give me dismissed. Alright, here's the full code. Here's the full code with the import statement and everything for this program. You have a sample solution posted on the LMS. Alright, now let me do one additional small project. So let me keep this project. Actually, let me remove this code over here. I have the scanner, and let's assume that I need to take from the student, from the user, sorry, a grade. Alright, a grade. So here's my prompt, system.out.println, enter or enter the MTA grade, the midterm grade. Enter the midterm grade. So let me read it. Grade is equal to input dot next double. Now I know that an MTA grade cannot be negative, and let's assume that the midterm was over 100. So the grade cannot be more than 100. You see, I have two conditions. So I need to test using one if statement both conditions, and I need to present whether the MTA is valid or not, or maybe I can do anything else. But first I need to validate this grade. So one parentheses for joining two conditions. These parentheses are for the first, these parentheses are for the second. So I have two conditions. Now I will add in between both conditions. The grade to be valid, it should be less or equal to 0, and the grade to be valid, it should be less or equal to 100. So since I need both conditions to be valid, both at the same time, I would use the AND symbol. You see, now I have, if the first condition and the second condition, I can provide system.out.println, for example, valid grade, and else otherwise system.out.println invalid grade. You see, I'm checking both conditions. So this is how inside an if statement, you see, the if should be either true or false. So the AND is going to give you one outcome. When both are true, the outcome is true. When one of them is false or both are false, the outcome would be false. So let's run and test this. You see, enter the MTA grade. Let's assume I took 68. Okay, I use println here. Let me use print, sorry. Let's run it again. Alright, so this is 68. This is a valid grade. Let's run it again. Let's make the first condition. See, 68 was valid because it is between 0 and 100. Let's make the first condition false. Let's say -9. You see, invalid grade. A grade cannot be negative. And let's make the second one false. Grade should be less or equal to 100. Let me put 109. You see, invalid grade. So let me put another value in between. 75. 75. It is greater or equal to 0. Yes, true. It is less or equal to 100. Yes, true. So now both conditions are true. This is a valid grade. Alright, so this is basically it for this first part of meeting 3. Make sure to watch the other recording of meeting 3, and make sure to go back to all the slides, cover them all, go over the exercises and do all the exercises as well. Thank you for watching this video.